Chapter 9, Section 1 is about quadratic graphs and their properties. This is a 2-day lesson, so we'll just talk about the small stuff at the beginning, and then we'll do a little more word problem practice on part 2. Okay, so a cat walks along the railing of a balcony and it knocks a flower pot off the railing. The function h of t equals negative 16t squared plus c gives the height of the flower pot after t seconds when it falls from a height of c feet. How long will it take the flower pot to reach the ground? Okay, this is something we want to think about while we learn about this lesson, and we can come back to it towards the end. All right, so your key concept for today is the standard form of a quadratic function. We have talked about quadratic functions before. They are these ax squared plus bx plus c, as long as the a is not a 0. Okay, now these are all different forms. Just this x squared itself makes it a quadratic function. So these are all different forms of a quadratic function. Okay, the parent function, if you remember what parent functions are, is just the y is equal to x to the second power. Okay, so that's like the ax to the second power. Now you could have plus bx plus c, but if those are all 0, then y equals ax is just our parent function, or what it looks like without anything else added. It creates what we call a parabola, which is this U-shaped graph here. And it has something called an axis of symmetry. And if you remember from art way back, symmetry is when you could fold something in half and it was the same on both sides. That's exactly what they're talking about here. The axis of symmetry is the fold or the line that divides the parabola into two matching halves. In this picture, it happens to be the y-axis. It won't always be, but it will be a place where you can fold it so that it's the same on both sides. All right, the vertex, last vocab word for today, is the highest or lowest point of the parabola. So you're going to have something that either looks like this or like this, depending on your a value. And this vertex would be the very lowest or highest point. All right, now, to know if you're going to have a minimum or a maximum, you look at this a value. Okay, a positive number or a number higher than 0 will give you a minimum, meaning that it will open upward, so your vertex will be down at the bottom, the lowest point, minimum. Okay, if you have a negative a value, that means that your parabola is going to open downward and you will have a maximum, so the vertex will be at the top, the highest point. Okay, so now we're just going to work on identifying those. First of all, they give you the graph. They ask you to identify the vertex and tell if it's a minimum or maximum. Well, our vertex hits right here, which is over 0 up 3, and that is up on the top, so that is a maximum. Letter B, our vertex, our lowest point hits right there, which is over 1, down 1, and it's at the bottom, so that is a minimum. Okay, so what do you think the vertex of this graph is, and is it a maximum or a minimum? Take a second here to decide that and come back and check your answer. Okay, the ordered pair for this point right here, which is the lowest point, meaning it is a minimum, is -2, -3. Okay, the second thing we're going to work on today is actually graphing these just using a table. Okay, so this one gives the function y equals 1/3 x to the second power. We're going to make a table of values, okay? You can decide what numbers you're going to use. They chose 0, 3, and 6, and they plugged them in. When I plug in a 0, they got a 0, so their first point went at 0, 0. When they plugged in a 3, they got a 3, so their second point went at 3, 3. Then when they plugged in a 6, they got a 12, so their third point went at over 6 up 12. Then you get to just reflect all of those points across your axis of symmetry. Okay, so we know that this is where we would fold it, and then we can see the other points exactly the same spot on the other side. All right, so if we're going to graph one of these. The second one, it says y equals negative 3x to the second power. Let's do that over here. X, y equals negative 3x to the second power with a y value over here. Okay, so I'm gonna pick 0, 1, and 2 just to be simple. Okay, when I plug in a 0, we have negative 3 times 0 to the second power, which also gives me a 0. Then I have negative 3 times 1 to the second power, which gives me a negative 3. And negative 3 times 2 to the second power gives me a negative 12. Okay, so on my graph, I'm going to put a point at 0, 0, over 1, down 3, and over 2, down 12. 10, 11, 12, so over here. Okay, and then I'm going to connect those with arrows because we know this goes on forever. Okay, because this had a negative a value, we know that this is going down, which we can see as we graph it. And we're going to use this as our, or that is our line of symmetry. So now we're going to reflect over and put our points right across. So it looks like a mirror image. All right, that's all you're going to have to do for the graphing for today is you're just going to have to use a table. But some things that you should know, the coefficient of the x squared term, so the a of x squared, this a in a quadratic function affects the width, how wide your parabola is, as well as whether it opens upward or downward. If it says if the absolute value of m is less than the absolute value of n, then the graph of m x to the second power is wider than the graph of y equals nx to the second power, which just means that the smaller the number, they open wider. Okay, so we're gonna go through a couple of these and you just have to try to pick out which ones are which, judging by their a value. Okay, so if I look, following that rule, we just had the smaller numbers open wider. So the smallest number in here for our a values is this 1/4, which means it should be the widest graph. Here's our largest number, which means that will be the narrowest graph. And then this one's in the middle. That's just a 1, so that one's the one in the middle. Okay, also notice this had a negative a value, so our parabola opened downward. Well, these two both were positive, so they both opened upward. All right, last one for today. I want you to look at these numbers and figure out in order the widest to narrowest of the graphs. Remember that the smaller the number, the wider the graph. So pause it here, put these in order from widest to narrowest, and then come back and check your answers. All right, because negative 1/3 is the smallest number up here, that is the one that's going to be the widest. And because positive 3 is the largest number, that's going to be the narrowest, leaving us with the negative x to the second power in the middle. Now, if you can remember, this is not one of the questions, but which ones of these are going to open upward and which are going to open downward? These negative ones are both going to be downward, and this one is going to be upward. Okay, that's the end of part 1. You can look at page 538, 7 through 28, 34 through 39, and the lesson quiz. Get what you can done today, and then we'll finish the rest.